Hello Vivek, welcome to YourPedia. Let's start your snap on electrical machines for your BPSC lecturer job.
Thank you, sir.
So the very first question is, which generator is used for the purpose of power generation mostly in India?
Sir, synchronous generator.
Okay.
That is alternator.
Why it is used? Why not induction generator or DC generator?
क्योंकि सर सिंक्रोनस जनरेटर ज्यादा बड़ा अमाउंट में पावर को जनरेट कर सकता है और वो एसी में वर्क करता है, इसलिए हम लोग सिंक्रोनस जनरेटर का यूज करते हैं.
So induction generator is not in a position to generate more amount of power?
नो सर, इंडक्शन जनरेटर नहीं कर सकते.
What is the limitation?
सर इंडक्शन जनरेटर को उसमें वेरिएबल स्पीड आ जाता है. उसका स्पीड जो है वो सिंक्रोनस स्पीड से कभी कम हो सकता है, कभी ज्यादा हो सकता है. लेकिन अल्टरनेटर जो है वो एक कांस्टेंट स्पीड पे रन करता है और वेरिएबल पावर फैक्टर पे भी रन करता है, इसलिए फ्लेक्सिबिलिटी ज्यादा होता है अल्टरनेटर में.
What is the problem if speed is variable?
अगर स्पीड वेरिएबल होगा तो फिर वहां पे पावर जनरेशन में प्रॉब्लम हो सकता है.
What kind of problem we get?
सॉरी सर.
What is the difference between generator and alternator?
अल्टरनेटर जो होता है सर वो एसी पे वर्क करता है, लेकिन जनरेटर हम लोग डीसी जनरेटर में भी यूज कर सकते हैं. और अल्टरनेटर जो है लार्ज अमाउंट ऑफ पावर को जनरेट करता है, लेकिन जनरेटर जो होता है डीसी जनरेटर वो लार्ज अमाउंट ऑफ पावर को जनरेट नहीं करता है.
My question is, what is the difference between simply generator and alternator?
ये नहीं पता सर.
Okay. Does in three-phase transformer, rotating magnetic field will produce in three-phase transformer?
नो सर.
Why?
Only magnetic field is produced. That is magnetic mutual flux, which link both the primary and secondary. क्योंकि यहाँ पे कोई rotating part नहीं होता है.
My question is rotating magnetic field. So you mean to say for the production of rotating magnetic field, rotating part is required for sure?
RMF तो ट्रांसफार्मर में प्रोड्यूस नहीं होता है यहाँ.
What are the conditions for the production of RMF required to satisfy?
थ्री फेज इंडक्शन मोटर में सर RMF प्रोड्यूस होता है, क्योंकि वहाँ पे हम लोग थ्री फेज सप्लाई से रिएक्टिव पावर कंज्यूम करते हैं.
In three-phase transformer also we are giving three-phase supply.
हाँ.
See, my question
लेकिन यहाँ पे सर RMF प्रोड्यूस नहीं होता है.
why? Why the reason?
The reason ये है कि ट्रांसफार्मर स्टैटिक डिवाइस है.
Yeah, transformer is a static device. What are the conditions to get the RMF?
सर इसका जो पोल होना चाहिए वो रोटेटिंग होना चाहिए.
So is the condition for the production of RMF?
Yes, sir.
Okay. See, in transformer and induction motor, which one is going to have a good power factor comparably?
सर अगर हम नो लोड पे भी बात करें या फिर लोड पे बात करें तो ट्रांसफार्मर का पावर फैक्टर ज्यादा बेटर होता है कंपेयर टू इंडक्शन मोटर.
Why?
सर क्योंकि ट्रांसफार्मर में एयर गैप कम होता है एज कंपेयर टू इंडक्शन मोटर. तो यहाँ पे सर जो मैग्नेटाइजिंग करंट है वो भी कम होता है, इसलिए यहाँ का जो पावर फैक्टर होता है वो ज्यादा बेटर होता है ट्रांसफार्मर में.
Fine. See, for a three-phase induction generator, I want to supply reactive power.
थ्री फेज इंडक्शन जनरेटर में रिएक्टिव पावर. यस सर.
For that, I'm using capacitor bank.
यस सर.
So how to connect that capacitor bank, in delta or star?
सर स्टार में कनेक्ट करें कैपेसिटर बैंक को।
Why in star? Why not in delta?
सर स्टार में वोल्टेज कम लेगा, डेल्टा में सर ये लाइन वोल्टेज लेगा।
See, what to do with the voltage and this type of connection? See, we are keeping that capacitor bank for the purpose of reactive power supply to the induction machine so that it can work it as a generator, induction generator, right?
यस सर।
Fine. Why single phase induction motor is not self-starting?
सर सिंगल फेज इंडक्शन मोटर में दो टॉर्क प्रोड्यूस होता है, एक फॉरवर्ड टॉर्क और एक बैकवर्ड टॉर्क।
Okay.
और यहाँ पे दो फिर इसकी वजह से दो फ्लक्स जनरेट होता है फॉरवर्ड और बैकवर्ड में। तो दोनों जब रोटेट करता है तो दोनों एक दूसरे को कैंसिल कर देता है, इसलिए यहाँ पे स्टार्टिंग टॉर्क ये नहीं होता है, मतलब स्टार्टिंग टॉर्क प्रोड्यूस नहीं होता है, इसलिए सेल्फ स्टार्टिंग नहीं होता है।
Okay. See, I have an alternator.
यस सर।
Connected that one to a long transmission line.
यस सर।
Okay. And at the receiving end, we connected some load.
यस सर।
And that load is lagging load.
यस सर।
Okay. Now we connected one voltmeter. We connected one voltmeter to the transmission line.
यस सर।
Now I am removing that load.
यस सर।
Now tell me about the voltmeter rating. Does the voltmeter rating will increase or decrease if load is removed?
सर जब लोड कम होगा तो उस केस में थोड़ा सा स्पीड जो है वो कम होगा, और स्पीड जब कम होगा तो वोल्टेज थोड़ा सा बढ़ जाएगा, स्पीड ज्यादा हो जाएगा जिसकी वजह से वोल्टेज थोड़ा बढ़ जाएगा।
Okay. I have a synchronous generator. I
Yes,
connected that one to grid.
यस सर।
The load on the synchronous generator is increased.
यस सर।
See, then can you explain what will happen? See, at generating station, yes, it will take some time for the input to increase, but all that happened. But now load got suddenly increased. Whether load will get its required power supply or not.
यस सर, अगर हम लोग इनफाइनाइट बस बार या फिर ग्रिड से कनेक्ट करते हैं लोड को, और लोड जब बढ़ेगा या फिर लोड जब कम भी होगा तो इसमें ज्यादा फर्क नहीं आएगा, क्योंकि अगर यहाँ पे अगर हम लोड बढ़ाते हैं तो उसी हिसाब से वो इनफाइनाइट बस बार में वो अपने वोल्टेज को इंक्रीज कर लेगा, और जैसे अगर हम लोड कम करते हैं तो उसी हिसाब से इनफाइनाइट बस बार में अपने सप्लाई को कम कर लेता है, मतलब वोल्टेज जो है वो मेंटेन रहता है।
No, I'm not talking about voltage. See, I have a load. I have a generator. Forget about infinite bus. Load and generator. Single generator and single load. We connected these two. Now suddenly I increased load. Previously it was 100 watts. Now I made it as 110 megawatts. Now instantaneously the load.
सर आप ये बोल रहे हैं जैसे हम सिंक्रोनस जनरेटर को और लोड को कनेक्ट कर रहे हैं?
Yes, electric load it is.
अच्छा।
I have a load of 100 watts. I
Yes,
connected
sir.
that one to synchronous generator. Now,
Yes, sir.
all of a sudden, I increase load from 100 watts to 110 watts. Now, does that required power to the load will come, or it will take some time for the power to come?
नहीं, यहाँ पे टाइम नहीं लगा, क्योंकि सिंक्रोनस जनरेटर जो है वो सिंक्रोनस स्पीड पे रन करता है।
You meant to say, oh, my question is about load. I'm not asking about the speed. See, for example, let's take this situation. In your state or in your city, there is 100 megawatt load.
Yes, sir.
All of a sudden in the evening, all of you switched on the lights, fans, and ACs in the evening. Suppose. Now the load on the system suddenly got increased.
Yes, sir.
And all of a sudden you are getting power supply also.
Yes, sir.
But at the generating station, input to the generator cannot be increased suddenly. It will take some time.
Yes, sir.
But you are getting your required power supply.
Yes, sir.
My input is 100 megawatt only. Previously, your load also 100 megawatts. Forget about the losses. For time being, losses are ignored. Now, all of a sudden, I changed my load to 100 to 110 megawatt. Right?
Yes, sir.
The input is at 100 only. But because for the input to change from 100 to 110, it will take some time. So, according to law of conservation of energy, at the input side, 100 megawatt only is there. But at the output side, we are getting 110. Because if you switch on the fan, your fan is rotating immediately. Are you making a phone call to generating station and you're telling that I am switching it on, please increase the input? Are you informing prior?
No, sir. No.
Suddenly we are switching on, suddenly we are getting the supply.
Yes, sir.
But input cannot change suddenly because input is associated with, suppose if you take thermal power station, the burning of coal, generation of steam, a lot of pressure, there are a lot of things to maintain.
Yes, sir.
So here law of conservation of energy is failing. 110 you are getting, input is 100 only. This extra 10 megawatts, who is giving and how we are getting? First of all, we are getting or not? If we are getting, who is giving the 10 megawatts of extra power?
Sorry, sir, इसके बारे में नहीं पता है.
Okay. So let me give you feedback, Vivek. Okay. I'll come from the last question. Now, when the load suddenly increases, speed of the machine will decrease.
Yes, sir.
Speed is decreased means, suppose previously the speed was 1500, suppose say.
Yes, sir.
Now speed, see, kinetic energy of the machine is associated with speed.
Yes, sir.
Kinetic energy is equal to half mv square if you are taking linear velocity v.
Yes, sir.
When load increases, when electrical load increases, speed is decreasing. Speed is decreasing means kinetic energy got decreased. Na?
Yes, sir.
That decreased kinetic energy is converted to electrical energy. Law of conservation.
Yes, sir.
Why that rotor is getting slowed down? Because there is more load, more electrical load on that. To supply that electrical energy, it is converting its mechanical or kinetic energy into electrical energy.
Yes, sir.
But if it is keep happening, frequency will down by a lot. Therefore, our machine will be disconnected from grid. By that time, it is decreasing. Slowly, input also will increase, and the increase in input again will make the speed to reach to synchronous speed.
Yes, sir.
Take your bike as an example. You are running with a speed of 50 km per hour with constant acceleration. Means you kept your acceleration constant. All of a sudden, I am putting some 100 kg extra on your bike will get slowed down or not?
Yes, sir. Slow हो जाएगा.
Why? Because your bike is carrying that load, but speed decreased. Why? That kinetic energy of the bike means the energy which is spending on velocity will be converted, and that is kept on supplying the load or serving the load. If you further increase your acceleration, then again that suppose speed from 50 to 40 got decreased. Load it is carrying, the increased load it is carrying, but with a decreased speed.
Yes,
if you
sir.
raise the input, it will take some time to raise the input. If you raise the input, again it will catch from 40 to 50. In the
Yes,
same
sir.
way, if all of a sudden load increases, then load will get supply. Who is giving that supply? Obviously, input is not giving. Why? Because for the input to give, it will take some time. Why? Because mechanical time constants, thermal time are very high when compared to electrical time constants, right?
Yes, sir.
Yes. So this kinetic energy which is stored in the rotor body is getting converted from mechanical to electrical.
Oh.
Yes.
10 मेगावाट मतलब kinetic energy दे रहा है.
Yes, that kinetic energy will be getting converted to electrical.
Electrical energy.
If it is continuously, see, that kinetic energy is not infinite and it is not going to support for a long time. For that sharp transient amount of time only. By that time, input will catch, input will rise.
Yes, sir.
And again,
Yes,
rotor speed will increase, rotor will attain its kinetic energy, and frequency is maintained constant. Your machine will be in synchronism with grid.
Yes, sir.
Got it?
Yes, sir.
Yeah. So why single phase induction motor is not self-starting? Okay. The capacitor bank we are going to put in delta, not in star. Why, you know? Suppose if you take resistances in star, 10 ohm, 10 ohm, 10 ohm in star will be 30 ohm, 30 ohm, 30 ohm in delta, right?
Yes, sir.
But for capacitance, it is exactly opposite.
Opposite. Half.
Means if you want to connect in delta, less amount of capacitance is sufficient to supply the same amount of reactive power, right?
Yes, sir.
I repeat, resistance of 3 ohm, resistance of 10 ohm, 10 ohm, 10 ohm in star will be equivalent to 30, 30, 30 in delta. Means if you want to have same power, star in star take 10, 10, 10, or in delta you take 30, 30, 30. Which one is best? 10, 10, 10 only, na?
10, 10, 10, 10. Yes, sir.
Same power only. But it is exactly opposite for capacitance.
Capacitor, yes,
Suppose
sir.
if I am taking C in delta, in star I have to take 3C, 3C, 3C.
Yes, sir.
Or if I am taking C in star, I have to take C by 3, C by 3, C by 3 in delta.
Yes, sir. Yes, sir.
For the supply of same amount of reactive power, the amount of capacitance required in delta is 3 times less when compared to star.
Yes, sir.
That's why we have to prefer delta connection. Capacitor bank, what we are taking is in delta connection, right?
Yes, sir.
For the production of 3-phase rotating magnetic field, these are the conditions. We must have 3 currents which are having phase displacement of 120 degrees. And we must have 3 windings which are having physical displacement of 120 degrees. These are the 2 conditions to get a 3-phase rotating magnetic field. If you go for 3-phase transformer winding is done on same core, where you are not going to get
phase shift,
physical displacement of a winding displacement of 120. You are going to have a phase displacement of 120 degrees in the currents. You are going to use 3 currents, 3-phase currents, 3 currents, which are having a electrical displacement or a time displacement of 120 degrees. But physical winding displacement 120 degrees is not possible. That's why 3-phase rotating magnetic field will not be produced in transform, 3-phase transform. Okay?
Yes.
What is the difference between generator and alternator? If armature is rotating, fields are stationary, it is generator. Simply DC generator. If armature is stationary and fields are rotating, that is alternator. Synchronous generator, simply.
Sir, synchronous generator और synchronous alternator जो है वो same होता है ना?
You need not to say synchronous alternator, synchronous generator and alternator both are same.
मतलब जैसे आप क्वेश्चन पूछे थे अल्टरनेटर और जनरेटर के बीच का डिफरेंस, तो हम सिंक्रोनस जनरेटर और डीसी जनरेटर के बीच का डिफरेंस बताते हैं.
Even if that is also in DC generator, armature is rotating. Otherwise, that commutation process will not take place, right?
सर हमको ये पता था दोनों का डिफरेंस, लेकिन हम कंफ्यूज हो गए सर अल्टरनेटर और सिंक्रोनस जनरेटर में सर.
Okay. Another question is, why not induction generator and DC generator? Why synchronous generator? Why? Because if the speed of the machine is not constant, if you take induction generator, frequency of the output is not constant. If frequency is not constant, we are not in a position to connect that one to the grid. And yes, we must need, I can say, alternating speed input to the induction generator. Right? Okay. DC generator, anyhow, DC is having lots of problems, like a collection of EMF is difficult, commutation process. Yes.
Yes, sir.
Sparking problem. There are lots of problems for DC generator. And we are not using
Brush
DC
loss, yeah.
directly. We are not using DC directly. Again, we have to convert that DC to AC to our required frequency. Again, that connect that one to grid. Induction generators are used where the input to the machine is variable. Suppose if you take wind speed is always variable.
Yes, sir.
Yes. So there I can use induction generator. And how to connect that induction generator to grid? You are getting some AC, convert that one to DC. Again, that DC to AC. AC, DC, AC cascade is required. Why? Because the induction generator output frequency is not constant, it is varying. If I want to connect my machine with grid, I must have constant frequency. That's why convert that AC to DC first. How to convert? By using rectifiers and filters and all. Again, convert that DC to AC to our required frequency. Which equipment it will convert from DC to AC? Inverter. Okay. To our required frequency. Then you can synchronize your induction machine to the grid. Fine.
Yes, sir.
So Vivek, lots of improvement is required. Okay, accelerate your preparation. Go in depth with the concepts. You are going for a lecturer job where it is expected from you to explain to the students at that level subject clarity is required. Okay.
Yes, sir.